Good morning, I am Kimberly Carr, and just before we get going, I'm just going to show you that when I am writing on the screen, I hope you'll give me a little bit of patience because I'm actually writing on this black tablet that has no lines, doesn't look anything like my screen, using a stylus and this weird glove so that it doesn't smear everything along the way. But it seems to work most of the time. Just have a little bit of patience with me. And I'm going to share a screen. Whenever I share a screen, I usually will start with the screen already up because it takes it about 7 seconds after I click it for it actually to show up. So you should start to see something that looks like a PowerPoint. And I'm actually just kind of going to edit as I go through. Now this PowerPoint has some of the exact same information that's on the ones provided by Pearson, but it's not the exact same PowerPoint. I do some things a little bit different, try to make it a little bit shorter or a little bit more focused into your homework. So I hope you find it helpful. This is our introduction to statistics. This is rather lengthy because it's a lot of words. And that's really where we have to start. Statistics kind of has its own vocabulary, and we want to get going with that. Why do you have to take this course? Well, it's not just you here at this school. Kind of nationwide, there's been a new push for learning statistics, but not so that you can become a statistician. That's a very different level of it. What we're really doing is wanting you to not be fooled by numbers just because people throw them at you. And a lot of people are just kind of intimidated by hearing the numbers. But consider the couple of statements I have there on the screen. Statistics don't lie, but statisticians do, or at least they can. Or maybe statistics don't lie, they tell whatever truth you want them to tell, because you can choose what sort of numbers you give to people. And of course, if you're trying to convince them of something, you only give them the ones they want to hear. If you can learn what the studies themselves mean, then you can go back and read that information. You know, and my grandma just loved to always say, consider the source. And that's kind of what we're wanting you to do, particularly, why are they telling me this? Is this everything? And does this make sense? So our next little slide here is just a quote to point out to you that sometimes people do not even reread what they've written, and that includes with numbers. This one was a percentage that was given in a paper. 78%, the percentage of female veterinarian students who are women. Okay, so maybe we need to learn how to check our numbers. This is a little bit blurry possibly to you. It's a lot of words. I've really just copied this from the textbook. If you don't know how to get to your online textbook, you let me know. It is available to you in the Pearson My Math Lab, and so I can show you how to navigate around if you have trouble finding it. But it's an e-textbook, full text. So we have several definitions here. I know you can read. You can pause this and read every word if you want to. I'm going to hit it kind of quickly. Data is all the collections of measurements and numbers and responses actually that we get, because it certainly doesn't have to be numbers. Statistics as a field of study has to do with planning studies and experiments. We're going to spend a lot of time on that one during this particular lesson. It has to do with obtaining data, organizing, summarizing, presenting, analyzing, and interpreting those data and drawing conclusions about them. Since this is an introductory statistics course, that really is the focus of what we're learning along the way. But I said statistics as a field because within the field of statistics, some of the numbers that we come up with, we will refer to as statistics, and some of them are something else, and that has its own definition we'll get to later. A population is all of the members of your group. And your group in statistics class has to be very carefully defined. You can't simply say like United States adults. You have to specify, because you know some people are becoming adults every day, and so you would have to say United States adults as determined by those who are age 18 and over as of January 1, 2022, or something like that. So it has to be very specific, but then it's every member within that group. Now, a census is when you collect the data from every member of the population, and that's very difficult. In fact, the United States says they have a census every 10 years, but in reality, that's what they're attempting to do. They actually never are successful in getting data from every member of the population. Because for one thing, the population as a as a group of people is constantly changing. Now, a sample then is what we are most often working with, and that is any sort of a sub-collection from that population. You can have a really large sample so that it's almost a census, but really what we want to do is get a large enough sample that it reflects the population, but that the numbers aren't so huge in general. And so that's typically what we will deal with in this course. Anytime I copy something from the textbook, again, I'll try to quit saying this all the time, but it gets a little bit blurry when I put it on the screen, and yet I think it's important because this is exactly what some of your homework looks like. In a survey of 1,046 adults conducted by the Bradley Corporation, subjects were asked how often they wash their hands when using a public restroom. 70% of the respondents said always. Okay, so your question asks you to identify the sample and the population. So our population, which I'm going to put parentheses around, is the group that you're wanting to study. You're not really just wanting information about the people in this study. You're wanting the information about the adults. Okay, that would be your population. And then the sample, which we will highlight in yellow, is the part of that population that you actually end up with in the study. So our sample is the 1,046 adults. Now, why would better results be obtained by observing hand washings instead of asking about it? That's because we feel like there is a right answer. Did you wash your hands? Do you always wash your hands when you use a public restroom? Well, the answer is supposed to be yes, and we know that. And so really people feel pressure, maybe ashamed to tell you the truth, and so they may have fudged and said they always wash their hands when they don't always. So it's better to not have people self-report if possible. Now, as we start to look at the statistical study process, there's 3 large categories, and the next several slides are going to take each one of these sections and break it down into smaller pieces. So prepare, analyze, and conclude. Prepare, and we've got more slides for that, but prepare has 3 major sub-areas. You need to consider the context, the source of the data, and the sampling method. So what does it mean, consider the context? Okay, what does the data represent and what's the goal of the study? You have to stop ahead of time. Rather than just do a study, you need to determine, what are we trying to find out? And when people give us these numbers, what specifically does it represent? You can't be very general because numbers, we're going to have numbers all over the place. You have to know exactly what they represent and what we're trying to determine. The source of the data, where are you going to get this information? You might get it from surveys that you did orally, by telephone, or by paper. It's possible, though, that you go through records from the past, maybe the census, or maybe an employer has employee records. So sometimes data is already there, we just haven't dug through it. So you just have to consider, where are we getting this information? And then how will we get the information, is the sampling method. So let's just kind of talk, though, on context then. When we say, what do the data represent and what's the goal of the study? Let's take that a little bit closer. Whenever you are reading about a study, you need to look very closely at the labels. Maybe they've already done this study. They needed to label it. And then what were they trying to find out? Down here we have data from a study. There's no sort of analyzation of it, it's just numbers. So what does it mean? What's the data represent? Well, we have pleasure boats. Do notice carefully that it's in tens of thousands. You always need to read something like that, because if you just glance at the numbers, 99 and 92 don't seem that far away, but 99,000 and 92 are significantly different. We want to look very closely at labels, and then the manatee fatalities. Then you're wanting to look at the relationships. So what we see here is that all of these values for the pleasure boats seem to be somewhere around, not exactly, but around 90,000 to 100,000. None of them go up to 100,000, but I do have 99,000. So between 90,000 and 100,000 roughly, we end up with somewhere between 70 to 100 manatee fatalities. And as you look, these highest ones, 99,000 then is the highest value here. But this has a 73 as opposed to that 92. Neither one of those actually has the highest. So it's not always true that the highest number of pleasure boats is going to give me the highest number of fatalities. But maybe we're just looking to say that in general, if there are a lot of pleasure boats, there are going to be some manatee fatalities. Okay, so that's our context. What are the labels? What's the relationship between the numbers? The next thing was the source of the data. You need to consider who published this, and we're going to go back and look at that information. Does the source have a special interest? Is there pressure to obtain certain results? For example, is that a pleasure boat company that published that study, and so they want you to feel like that the manatees are really, really safe? You just have to consider, where is this information coming from? And when we look at that, even though it didn't say it at the time, I just didn't put it up on the screen, this information was from the Florida Department of Highway Safety and the Florida Marine Research Institute. Now, neither of these companies would want there to be no pleasure boats. Pleasure boats within the area of Florida, and this is a Florida State Department then, pleasure boats are a big business, and it's a big community economy boost. So they don't want there to be no pleasure boats. So this would be, they're not against pleasure boats, but they're not selling them either. Both of these companies would have a pretty objective viewpoint. They're just trying to find out what's happening. They don't seem to necessarily care either way. So that's a good sign. Then when you're looking at the sampling method, whether or not you are preparing to do a study or they have done the study, you need to find out how to collect the data in an unbiased way. That has a lot of detail within it, but it's very important that the data is not biased. If it's biased, it really doesn't mean much. So what do we mean by biased? Well, I think these little memes underneath here probably say it all. Did the participants volunteer? Oh, pick me, pick me, pick me. That's a little bit different. And if you think about even maybe when you were in high school or earlier grade school, when a teacher asks for a volunteer, the person that volunteers is not necessarily the same personality as the person who will participate and do a good job if the teacher calls on them. So that's one thing to consider. It's just it's not to say that the volunteers don't give good information, but they're not necessarily representing everybody. Whereas if you pick people to participate, you can get a better representative of your population. Were the questions loaded? That's what we were talking about with the bathroom question. Did you wash your hands? There are some questions that you just feel like you know the right answer to it. And so you feel pressured to give that particular answer, even if it's not exactly the full picture. Do the participants themselves have something to gain or lose? I know that sometimes, well, when I was in college, all those years ago, somebody was working on a research project, and in one of my classes, they offered us bonus points if we would go participate. So bonus points, people that needed then the bonus points or wanted the bonus points, that type of student was more likely to go participate. So anytime participants have something to gain or lose, then you have a little bit of a skewed result. Again, you're trying to do whatever it takes to get a real clear picture of your full population. This is just going back to those volunteer response samples. Some of the common things that you hear results from in today's society are internet polls or mail-in, that somebody will send you something in the mail and you mail in your results. Or even on the radio, they will ask you to call in and give a result. anytime it's a volunteer response sample, which is also called self-selected, so if you volunteer or it's self-selected, you know, we're not saying it's wrong, but you have to question, is this really representative of the public? And so what's the problem with this type of sample? I just said it. It may not give you a real picture of your population that you're trying to get information from. This is an example then of something that is similar to what you might see in your homework. It's what term is used to describe this type of survey in which people surveyed consist of those who decided to respond, and what's wrong with this type of sampling method? Well, I actually don't even have to read all of the rest of it. Most teachers shouldn't tell you that. But if it says the people surveyed consist of those who decided to respond, okay, then that is called, and I'm going to see if I can write this up here, volunteer response. The other correct name is self-selected. So there's the answer to that question. What's wrong with this type of sampling method? There's a lot of ways you could say this, but it may not represent the population. And the population is whatever group you're trying to study. So now we will go back up and see what it was that they did. USA Today posted this question on its website: how often do you seek medical information online? Of this 1,072 internet users who chose to respond, 38% of them responded with frequently. Well, it's not very clear what the population was, but it sounds like they're trying to say, how often do people? Because it didn't tell us who the population was, so that's a little bit sketch. If they are trying to find out about people in general, though, right now the fact that they've posted the question online means they've only narrowed their sample to people who are actually using the internet. And then they've narrowed it further to people who read USA Today online. Then, as far as that would mean that probably more people that are reading their newspaper online would be people who seek medical information online also. You can see where you've left off people then who don't really use the computer that much. But what we could say is just internet users. However, even within internet users, if that's who their population is, we have narrowed it down to internet users who read the USA Today online, which is not all internet users. I use the internet. I don't read US Today online. Okay, so now let's go back. We've talked quite a bit about the other things. Let's look at our next thing. I'm just going to kind of flip back to, we just finished the prepare section. So now we're going to move into the analyze. Okay, so we have prepare, analyze, and conclude. Prepare was context, the source of the data, and the sampling method. After that, we move into analyze. Analyze also has three subgroups: graphing the data, exploring the data, and applying statistical methods. Now we're going to look some more at graphing some of the data in another lesson, but right now we'll just leave it that you know what graphs are, and there's several different ways to graph the data. Okay, so looking at exploring the data, we will spend a lot of time during this course learning to explore the data. Are there outliers? What are summary statistics? What's the distribution? Are there missing data? And did many of the selected subjects refuse to respond? Now, missing data is just when we don't have all the information, but selected subjects is a little bit more like when the teacher calls on you in class and you still don't answer. That's a different level of response than simply not volunteering. So if that happens very much, that's something to consider. We're not going into these a great deal today because we will spend chapters on doing some of this stuff about exploring the data. So exploring the data will take up a lot of our time. Then statistical methods, thankfully, we will be using technology to deal with our results. And there's a lot of ways to use technology, calculators, online calculators, simulators, stats crunch. There's just a lot of technology available today, which means that you will make fewer errors, because one of the things with statistics, since you deal with so many data, that it's easy to just have a typo or turn a number around, and technology at least helps us not to make some of the mistakes with just multiplying or squaring a number or something like that. So yay for technology. Now, analyzing will be something we spend a lot of time on then within the course of this class, but that's all we're going to say about it right now. The next part is conclude. When we conclude, it kind of relates into two different categories. For the most part, in statistics, we start to look at, do the results have statistical significance? And that can be defined in more than one way as far as an exact percentage, but the concept is over here in blue. If the results you get from it, from your study, whatever it is, are very unlikely to just occur by chance, then your study probably has significant results. Now, what is unlikely to occur by chance? Most of the time this textbook, and most of the time most textbooks use 5%, but they could use like 1% if they wanted to. They could use 2%, but it's always going to be small, okay? It's got to be very unlikely to occur by chance. Now, particularly as you're a consumer, one of the things you're also interested in is, do the results have practical significance? Just because it shows up numerically doesn't mean people are going to care. So it has to have enough of a difference, enough of a meaning that it justifies its use and it's worthwhile. And we say that because there are many things that we can find out would make a difference, but sometimes we as consumers are just like, yes, but not enough of a difference to cost that much money or something. So that's where we look at practical significance. Does it really matter to the public? Okay, and we will spend another chapter doing some of that also. So just to kind of finish up here, when you're dealing with statistics, you want to be very careful of misleading conclusions. Correlation does not imply causation, and that's a sentence that'll come back up another time. For example, people tend to make more money as they get older, so there's a correlation there. But getting older does not cause you to make more money, and making more money does not cause you to get older. They happen together. But just because two things seem to happen together does not mean one of them causes the other one to happen. Actually, most people make more money as they get older because they have more education and more experience. Also, be very careful about sample data that was reported instead of measured. Consider weight. And that's what I have as my example out there. And I'm sorry, ladies, but particularly a lady's weight. If you ask somebody what their weight is versus if you get somebody to step on the scale, typically there's a difference there. So anytime people report something themselves, and they also tend to round it off. Somebody is more likely to say they weigh 145 than to say they weigh 147. Be careful of loaded questions. We talked about that earlier. When you are just having a conversation with somebody, a lot of times we load our questions. We say, don't you think? Which lets the listener know we expect them to agree with us. But you don't want to do that in statistics. Also, be very careful about the order of questions. If you ask someone a question and they give you a response to that one, and then you ask the next questions, sometimes they seem linked, and their first response will go into that. You just have to be careful. We do have to ask questions in an order. You can't ask them all at once, but you want to make sure that you're asking them in an order that does not lead to a particular response. I've already mentioned non-response, especially refusals, okay? And then be very careful when people give you percentages. We had a little slide at the beginning where it said 78% of the females were women. But the other thing is percentages are very common, but people don't always deal with them well, especially on ads and advertising or results where they're trying to give you a percentage of an increase or especially a reduction. If something increases 100%, it doubles. But if something decreases 100%, it's gone. And the fact that it's not doubling or halving, can mess some people up. So you have to be very careful in double checking percentages and use your calculator to go along those ways. Okay, I think this will kind of cover your introduction, and let me know if you have questions. Use that Ask the Instructor at the bottom of your homework questions underneath the More tab if you need some help right away. Thanks. Bye, guys.